Hello again, and welcome to Crazy Math Productions. Today we're going to be looking at the point-slope form of a linear equation. Again, our theme for this chapter has been trying to write equations from various forms, looking at the table, looking at the graphed version of a line, looking at given information, whether it be a point, a slope, or y-intercept. We're trying to generate these linear equations, these forms. So today we have a little different way to write that linear equation. And in review, we've had the standard form, ax plus by equals c. That's a standard form. We have slope-intercept form, which is y equals mx plus b. And now we have this new form, point-slope form. Now, the point of this is you're trying to find a very quick version that's going to be a little less work than the um, slope-intercept form and much less work than the standard form as far as just taking a point and a slope and getting a quick equation. So the advantage of this is that you're going to generate an equation very quickly. The disadvantage is that it's not going to be useful. You cannot graph an equation very easily from this form. And if you're generating an equation, your equation is going to be different than your neighbor's depending on which point you choose. So there's going to be literally an infinite number of spin-off versions of the same equation, which isn't very nice. But again, if you're just looking for a quick equation, this is the way to go. And then, of course, you can translate from this form to the slope-intercept form or to standard form, whichever one you'd like to use. The first thing we're going to look at is how exactly is this generated? Now, let's use some actual values. Let's say the slope is 2/3, and we have this mysterious x1, x sub 1, y sub 1, and 3, 4. Now, what we're going to do is, given that the slope of the line is 2/3, so m equals 2/3, and given that we have x sub 1, y sub 1, and the point 3, 4, how can we generate this? Well, what we're going to do is this. We're going to take the traditional form of the slope, which is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, and that's going to give me the slope. Now, in this case, I don't want the slope. I already know what the slope is. It's 2/3. So how exactly do I use this? Well, of course, we could try to solve for x1, x sub 1, and y sub 1, but we don't want to do that. What we want to do is we want to multiply both sides by the denominator here, 3 minus x sub 1. Of course, if we write that in fraction form, rational form, we can divide these out. And on this side, we have 3 minus x sub 1. Now, we can switch this around. 4 minus y sub 1 equals, and we're going to use commutative property of multiplication here. We're using the symmetric property of equality there. 2/3 onto 3 minus x sub 1. And you can kind of see that we're starting to generate this form here. And now what we're going to do is we're going to use proof without the values. We're going to use x, y, first point, and another x, y. Now, we need to indicate which one we want to plug a number into, which one we do not want to plug a number into. So we're going to use these as the actual values that we would plug into. And then, of course, our slope is going to be m. So we're going to go ahead and generate this y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 equals the slope m. And again, we're going to do the same thing here. We're going to multiply both sides by x minus x sub 1. And again, make a rational version of this and divide through. That divides to 1. And we're going to use the transitive property of equality and the commutative property of multiplication. And you can see basically that using the traditional formula for the slope, we can generate this point slope form. Now what's interesting is, as new students start using this form, a question commonly asked is, well, which y do I plug into? For example, what if I had the point 3, 4 and the slope of 1/2? Now, students generally can tell that the slope is supposed to go here, but they get confused. Where exactly do I put the x and the y? Now, the y leave alone. The x leave alone. One way to think of this is that the one that has the number is the one where you plug in the number. So we're going to say y minus, and y sub 1 we'll use as 4. Again, it has a number, subscript, so that's where we'll plug our number that is constant. And again, m is 1/2 that we could use, and then x minus x sub 1 would be 3. So that at least gives you an idea, where do I put these constants into the equation? Well, you put them where the subscripts are. You leave alone what I've highlighted here. Let's actually try one. Example 1. And based on what you've done, what you've seen up there, you may be able to go ahead and try one. So you could try to pause the video and see how you do. And let's go ahead. This is going to be my x and my y. Now, again, I have to remember this formula, y minus y sub 1, oops, excuse me, equals m onto x minus x sub 1. Of course, if you forget, you can actually generate it from the traditional slope formula. And now, the one that has a subscript is where I'm going to put my constants, my numbers, and I'm going to leave the variables with no subscripts alone. So if it doesn't have a number, don't put in a number. If it does have a number, put in a number. Y minus y sub 1, which is 4, equals m, which is negative 2, onto x minus x sub 1, which is 5. And believe it or not, this is done. That's all we're looking for here. Let's look at number 2. Again, you may want to try to pause the video and see if you can do this on your own. Okay, we're going to generate as quickly as we can an equation of this line. So there's a couple things I need. Number 1, I need a point. And number 2, I need a slope. So the slope, I'm going to go ahead and draw my rectangle. It's a little easier for me to see what's going on. And now I'm going to rise 1, 2, 3, 4 boxes and run 1, 2, 3 boxes. So that means that my slope is going to be rise over run. It's going to be 4/3. And now comes the interesting part. I may choose from the given points here. I could choose the point -1, 4, or I could choose the point -4, 0. It's going to generate two different lines based on the two different points that I've been given. But again, it's completely up to you. You may choose either one. Let's go ahead and write down our equation. The point slope form, and go ahead and plug it in. Again, the variables with the subscripts. If it has a number, put in the constant, put in the number. If it has a number, put in a number. So I'm going to go ahead and choose this one. It doesn't matter which one you choose. Y minus y sub 1 equals m onto x. Again, that doesn't have a number, so don't plug in a number. Minus x sub 1 is going to be negative 1. Now I do need to clean this up before I continue. Y minus 4 equals 4/3 onto x plus 1. And there is my point-slope form of the equation. Okay, now what this is basically saying, it's usually you're going to generate very quickly an equation using the point-slope form, and then you're going to transform that into slope-intercept form, because that's a much more user-friendly if you're trying to graph a line, excuse me. It's more standard. If you are trying to generate an equation and your neighbor is trying to generate an equation, you're going to come up with the same equation if you do slope-intercept form correctly. So it's all-round slope-intercept is a much better form, but point-slope is very quick to come up with. So we're going to first put it in point-slope form, and then we're going to transform that into slope-intercept form, which is pretty common. Now write the slope-intercept form of the equation of a line that has a slope of 1/3. So m is 1/3, and goes to the point negative 3, 4. So I'm going to start with my equation. Y minus y1 equals m onto x minus x1. I'm going to use my point. Again, the numbers go into the variables with the numbers, with the subscripts. Y minus y1, which is 4. I'll go ahead and label that. Equals m, which is 1/3, onto x minus x sub 1, which is negative 3. And now I want to transfer it into point-slope form. Well, to do that, let's go ahead and clean this double sign here. That's going to be x plus 3. Keep change. And now we're going to distribute first. So I'm going to continue on this next line. Y minus 4 equals 1/3 x plus. I can put the 3 in rational form, 3 divided by 1. 1/3, 3 times 1 gives me 3 divided by 3, or just 1. First distribute, then add the opposite of your constant here to both sides. So I get, that would add to 0, additive inverse property, and then additive identity. Also, y plus 0 gives me y. I have y equals 1/3 x plus 5. And I have my finished version. So first I write it in point-slope form, then I distribute, add the opposite to get the slope-intercept form, which is much more useful. Again, go ahead and pause the video, try this on your own, and now we'll start. Slope, we're going to rise 1, 2, 3, 4, 5, 6. We're going to run 1, 2, 3, that is negative 3. So we rose positive 6, and we ran negative 3. So slope equals rise over run. Now 6 divided by negative 3 can be reduced. M equals negative 2. And here we go. We're going to pick one of the 2 points. It doesn't matter which one you want. I think I'm going to pick 1, 2, 3, 4, negative 1. And I have my point, my slope. I'm going to put it in point-slope form. Y minus y1 equals m onto x minus x1. Very important that you memorize this formula. If you don't, then this whole process is going to be very strained. Y minus y1, which is negative 1, equals m, which is negative 2, onto x minus x sub 1. Keep change. So we have y plus 1 equals negative 2 onto x minus 4. Again, 2 steps to get it into slope-intercept form. First, we're going to distribute. Then we're going to add the opposite. We have negative 2x. Negative 2 times negative 4 is positive 8. And then we're going to add the opposite. We're going to add a negative 1 to both sides. So we have y equals negative 2x plus 7. And that's my my slope-intercept form. And that will do it for today. Again, I would encourage you to go back through the video, pause, try them, and then rewind to make sure that you have gotten it correct. If you have not gotten it correct, rewind it, try it one more time. Thank you so much for listening to Crazy Math Productions.